Welcome back. Today we are covering Module 1.1, What is a Knowledge Cutoff? Let's dive in. Welcome to Module 1.1 of our series. Today, we're diving into a fundamental concept for understanding LLMs, the knowledge cutoff. Simply put, a knowledge cutoff is like a timestamp on an LLM's brain. It's the precise date up to which the model has absorbed information from its training data. Anything that happened after that date, whether it's a new scientific discovery, a major news event, or even a change in a celebrity's relationship status, is completely unknown to the model. It's as if time simply stopped for the LLM at that particular moment. So, why do LLMs have these cutoffs? It boils down to the sheer scale and cost of their development. Training an LLM involves processing petabytes of data, consuming immense computational power, and taking months, if not years. It's not like simply updating an app on your phone. Each training run creates a static snapshot of knowledge. Continuously updating these models in real time to incorporate every new piece of information would be astronomically expensive and logistically impossible. Thus, models are launched with a defined end date for their knowledge acquisition. The practical impact of this cutoff is significant. If you ask an LLM about the winner of last year's World Cup, a recent scientific breakthrough, or the current stock market trends, and that event occurred after its knowledge cutoff, the model simply won't know. It might give you information from an older event, state that it doesn't have the information, or even worse, it might confidently make up facts, a phenomenon known as hallucination. This presents a major challenge for any application needing real-time, accurate, and up-to-date information. To truly grasp this, let's look at how this manifests when we interact with an LLM. Imagine we're using a common LLM API. If we ask it about a specific event that just happened yesterday, or a new product launched last week, the model won't have that information. Its response will be limited to what it learned during its training phase, which, as we know, has a fixed end date. This is a crucial observation for anyone building applications with these models, as it dictates what kind of questions your AI can reliably answer. So, what's the solution to this inherent limitation? Thankfully, the story doesn't end with static knowledge. The field is rapidly evolving, and brilliant minds are developing innovative ways to augment LLMs, enabling them to access and integrate external, real-time information beyond their original training data. This is where techniques that allow LLMs to connect with dynamic data sources, databases, or the live internet come into play. This crucial development fundamentally changes how we interact with and deploy LLMs for applications requiring the absolute latest information. And that, my friends, brings us perfectly to our next lecture, Module 1.2, where we will dive deep into a paradigm-shifting approach called the RAG paradigm shift. Don't miss it.